Hi everybody, my name is Brandon Leafblad. I'm the co-founder of Audiofusion Systems, and this is today's Audiofusion Tech Tip. Let's talk a little bit about Wi-Fi Explorer Lite. Wi-Fi Explorer Lite is an app that we use to scan the Wi-Fi in your space to see which channels you should choose and what channel width you should use on the router. Let's take a look at that now. The Wi-Fi scanning tool that we recommend is called Wi-Fi Explorer Lite, which is a free download from the Mac App Store. You will need to get online, but just type in Wi-Fi Explorer and these ones will come up for you. We have used Wi-Fi Scanner, which is a great tool. I think that one's $19.99. The full version of Wi-Fi Explorer is $9.99, but for our purposes, Wi-Fi Explorer Lite is perfectly fine. So go ahead and download that, and we'll open it up. Now, when you open Wi-Fi Explorer Lite, you'll see the top half of the screen. It lists each of the Wi-Fi routers that are running in your space, or actually more specifically, it's listing separately each radio broadcasting from each of the Wi-Fi routers running in your space. So if you have a dual band router, it means that you have a router with one radio broadcasting down here in the 2.4 gigahertz band, and you've got one radio broadcasting here in the 5 gigahertz band. If you have one of the tri-band routers we recommend, then your router will have one radio broadcasting in the 2.4 and two radios broadcasting up here in the 5 gigahertz band. This lower half of Wi-Fi Explorer Lite is a graphic interface which shows you all the routers with a radio broadcasting in the 2.4 gigahertz band and all the routers with a radio broadcasting in the 5 gigahertz band. Now for Audiofusion, make sure that all of your devices running Performer are connecting to your Wi-Fi router only through one of the radios broadcasting in the 5 gigahertz band. Now, if we take a look at what's running here in this space, you can see that Wi-Fi Explorer Lite lists the name of the router. It will show you the relative signal strength based on the location of that radio relative to the Mac that's running the scan. So when you're running your scan, you want to physically put the Mac on stage or wherever your performers are going to be standing so that the calculation for relative signal strength is accurate. It shows you the channel you've selected for each radio and the bandwidth at which each is broadcasting. Now you can set each of the radios broadcasting in the 5 gigahertz band to run at one of three bandwidths, 20, 40, or 80 megahertz. But for the purposes of Audiofusion, 20 megahertz just isn't enough bandwidth to deliver real-time audio, so make sure yours are set to either 40 or 80. The max rate, that's the corresponding megabits per second. That radio can broadcast when it's set at that bandwidth. So broadcasting at 40 megahertz will reduce the max rate, which can limit the number of performers that you can connect to that radio. For any of the Wi-Fi routers that we recommend that you'd buy off the shelf, they can run in two channel ranges. They can run down here in this lower range, channels 36 to 48, or in this upper range, channels 149 to 161. Now each of those channels, channels 36, 40, 44, and 48, each of those represents 20 megahertz of bandwidth. For example, the router that I'm using to access the internet, I have it set to channel 149 and set to broadcast at 40 megahertz. So you can see that it's aggregating both channel 149 and channel 153 next to it. So it's using 40 megahertz of bandwidth and taking up two channels worth of range. Now, if we take a look at the Nighthawk that I've got running, you can see it's set to broadcast at 80 megahertz. And so it's actually aggregating all four channels of Wi-Fi. So if you set either the radios on your router to broadcast at 80 megahertz in the 5 gigahertz band, then you'll be utilizing all four channels in the available range. So if I were looking at this scan, if this is the Wi-Fi that was running in my space, I would look at the two channel ranges that are available to me, and I would see that there are radios already broadcasting here in the upper range, but there's really nothing broadcasting down here in this lower range. So I would set one of my radios on my router to broadcast at 80 megahertz wide, utilizing all four channels available to me in this lower range. And you can see here, these are the two radios from my Linksys router, and we do recommend giving each of your radios a separate name or SSID so that you know which one you're connecting with, instead of allowing the router to choose for you automatically. So I've got my Linksys router here. It's a tri-band router, and so I've got the radio broadcasting in the lower range. I've called it 5 gigahertz low, and I've got 5 gigahertz high running up here. You can see that graphically, using Wi-Fi Explorer Lite, that I've got this conflict with these other radios that are broadcasting in that range. And so what I'll do is, instead of running 5 gigahertz high at 80 megahertz wide, I can go in and change that on my router and try to keep from overlapping any of the other signals that I'm up against. So let's go ahead and go into Safari. Make sure that you're connected by Ethernet to your router, and then you can access the router directly simply by typing in the IP address. By default, it's 192.168.1.1. Go ahead and sign in with your administrative password, which will be different than the password you use to actually connect to one of the radios. And when you sign in, it'll come to the main setup page. Now, if you're using the Linksys router or the ASUS router or one of the routers that we recommend, we'll have separate videos talking about the specific settings for each of those. But I'm using the Linksys, so we'll use this one today. Open the Wi-Fi settings page. And the first thing that you're going to do is you want to turn off band steering, or your router's equivalent of Smart Connect, so that you can access separately the settings for each of the radios broadcasting in the 5 gigahertz band. You may want to turn off the 2.4 gigahertz band completely, or you could use that to connect with your mixer for the control surface. You just want to make sure that none of the devices running Performer are connecting to the 2.4 gigahertz band. Now, if you recall, looking at our scan, we didn't see any radios broadcasting in that channel 36 to 48 range. So we'll go ahead and leave 5 gigahertz low to broadcast on channel 36 at 80 megahertz. But if you recall, we had some conflict in that upper range. The 4 channels that are available to us commercially are channels 149 through 161, but we saw several radios broadcasting on channels 149 and 153. So we'll go ahead and set the radio broadcasting on our router to channel 161, and we'll change the channel width to 40 megahertz. So go ahead and apply those settings. You can see that we set Audiofusion 5 gigahertz low to run at 80 megahertz bandwidth. It's aggregating all 4 of those available channels to get a nice throughput. And you can see that we've set Audiofusion 5 gigahertz high to broadcast on channel 161 at 40 megahertz. And now it's coexisting very nicely with the other Wi-Fi that we have running in that upper range. Now you can set the bandwidth of each of your radios separately, and it's better to broadcast at 40 megahertz of bandwidth, not overlapping anything else, than it would be to set it at 80 megahertz and sitting on top of the other radios broadcasting in that same channel range. Now let's talk about this Nighthawk router that's running here in the middle. As I mentioned, the commercially available channels for Wi-Fi are channels 36 to 48 in this lower range and channels 149 to 161 in this upper range. So what about these channels in the middle? This channels 52 through 144. These are called DFS channels, and DFS stands for Dynamic Frequency Selection. They're channels that are unlicensed. They're channels that are available for use anytime they're not being used by any systems that are running radar. So you might be able to find a really clean channel here in the DFS range if your router is capable of doing that. But you are running a risk that if a police car drives by, or if that router detects any radar systems being used in the area, usually weather radar, the router will shut down this radio and move it out of the DFS range. And in the process of doing that, you'll lose signal on Soundcaster for 30 seconds to a minute. So keep in mind that Wi-Fi channels are regulated by local authorities. So while these principles will apply to any locale, your specific channel selections and configuration options will be different in your area. So we're going to do a separate video specifically about the Nighthawk X10, and that video will include all the options and capabilities of that router. But for now, we just wanted to let you know what the DFS channels are and how to use them and the risk that you might be running. Well, what do you do if your Wi-Fi looks like this? Obviously, that's going to be a little bit more difficult. You can see we have a ton of stuff happening both in this lower range and in the upper range of our 5 gigahertz band. I mean, we've got stuff running at 40 megahertz and 80 megahertz. And so it all looks very impacted. Well, you could try running a router that's using the DFS channels. But if you've just got one of the standard off-the-shelf routers that we've recommended, then your best bet might be to run both of your radios broadcasting in the 5 gigahertz band at 80 megahertz and try to go right over the top of everything else that's already there. It will be critical in this kind of environment to position the router on stage or as close to the stage as possible so that the relative signal strength will be higher when compared to that of the other radios that you're up against. So as we crank up our Linksys router, all right, so you can see that I've got my 2 radios running in the 5 gigahertz band. I've got, I've got Audiofusion 5 gigahertz low. I've got Audiofusion 5 gigahertz high. Now, I did notice that there are several radios broadcasting here at 20 megahertz that have a little higher signal strength that we should try to avoid. I've got both on channel 149 here, as well as on channel 36. So if this was the scan of the Wi-Fi in my space, I'd experiment with running the radios set to broadcast at 40 megahertz bandwidth and on the channels in the upper end of each of their respective ranges. So let's do that now. We'll go back into Safari. Go to our Wi-Fi settings and we'll set Audiofusion 5 gigahertz low to run on channel 48 at 40 megahertz wide. And we'll set Audiofusion 5 gigahertz high to run on channel 161 at 40 megahertz also. We'll apply those changes and we'll see how that shows up on our scan. Okay, so you can see I now have 5 gigahertz low and 5 gigahertz high, both set to broadcast at 40 megahertz, which is probably going to give us the least amount of conflict as we can get in a crowded Wi-Fi environment like this. But as I mentioned before, if you set your radios to run at 40 megahertz, it will reduce the maximum throughput that you can achieve, which will in turn limit the number of performers that you'll be able to connect. If you want to connect 8 or 10 devices running Performer in an environment like this, you should probably balance the load between the 2 radios by connecting half of your devices with the 5 gigahertz low and half with 5 gigahertz high. Now, if you were to connect the maximum number of devices, which is 16, then you would probably have to set both of your radios to run at 80 megahertz and balance the load between the 2, putting 8 performers on each radio. But if I was trying to connect 8 to 10 performers, this is how I would set it up if I was looking at a scan of an impacted Wi-Fi environment like this. The key is that by using Wi-Fi Explorer Lite, you can see visually exactly what's going on, which channels are being used, what conflicting radios you're up against, and how the changes that you make on your router will affect how your radios are set to broadcast.